All right, let's do this. Similarity and transformations, module 11. Number 1, what is the center of dilation? So they give you an image and a pre-image, and basically you could do this with a straight edge, or you could just do this visually. Remember, there's a certain direction or vector from A to A prime, B to B prime, and C to C prime. So if you draw a line between A and A prime, okay, pretend that's a line, okay? I don't have a straight edge, I'm just drawing on a touch screen. But basically, if you drew a line, notice how it goes through the origin, okay? Now let's do the same thing with B to B prime. If you draw a line through, you're going to realize, hey, it also goes through the origin. Coincidence? Let's find out. From C to C prime, draw a line, and it also goes through the origin. So notice that when you're expanding outwards from your image, or from your pre-image to your image, that's all coming out from a central location, okay? So your origin, 0, 0, okay, will be your center of dilation. Now for the scale factor, for number 2, when you're talking about scale factors, there's 2 ways you can do this. If you do this visually, and it depends on your teacher, it depends on where you're comfortable, okay? You can notice the distance from the center of dilation from point A to the origin is 1 diagonal, okay? But the distance from A prime to the center of dilation is twice the distance, okay? So since it's twice the distance, I'm already thinking my scale factor has to be 2. You could double check the rest of your points, because remember, all points have to go under the same scale factor. So from 0, 0 to B, you go up 1 over 2, and from the origin to B prime, it's twice that distance. Okay, you could also use the distance formula and solve it that way. But even just visually when you're looking at it, the origin from C is 1 diagonal, but the distance from the origin to C prime is twice the distance of C. So they're all going 2 times farther away from their center of dilation. That's a good cough. You're probably looking at a scale factor of 2. Now, for those who are algebraic, a little bit more Pascal, if you notice point A was at -1, 1, but then all of a sudden after you dilated, A prime becomes -2, 2. Okay, so you could also go like, well, what times -1 could get me -2? Well, if your k is 2, 2 times -1 would be -2. So that works. Okay. Hey, babe. That's my daughter.
Ow, ow, ow.
All right. So, sorry, she likes to get some attention, which is why I'm going to go so fast. All right. You can double check your y value. It also multiplies by k, which if it's 2, it will get you this 2 here. You double check all your points, just like how I did with A, and they should all be going by a scale factor of 2. That's another way you can check algebraically. Number 3, which is not preserved between triangle ABC to A prime, B prime, C prime. Well, it's dilation, so orientation, that's got to be preserved. Okay, so if you look up your picture, orientation just says this. Point A is in the top left, well, A prime is in the top left. B is in the top right, well, B prime is in the top right. And C is in the bottom left, and C prime is in the bottom left. That's all it's saying. So orientation, check. We're good. Side lengths, well, let's see. The originally AB was a length of 3, but then all of a sudden A prime, B prime is 6. Uh-oh. That changed, right? So remember, dilation, even if it just changes for one side, that's not preserved. All right, so we're looking for not. Orientation, check. Side lengths, nope. Nope. The only time side lengths will stay the same is if k equaled 1. Your scale factor was 1. Because 1 times anything is just whatever that one thing was. Didn't change. But that's not the situation. Betweenness. Betweenness means that, well, you have 3 points for A, B, and C. It's a triangle. So A prime, B prime, C prime should only have 3 points. Okay? If all of a sudden you had like a D come out of nowhere, it's like, yeah, let's go ahead and let's dilate a triangle, and then out comes like a magical star. Now you have like all these points. That's not betweenness. Okay? But this is not the situation. You dilate a triangle, you get a triangle. So between one another, they're both triangles. Awesome. 3 points. Angle measures. Angle measurements have to be preserved by the definition of a dilation, so that's good. The only one that's not preserved is side lengths in this situation. All right, number 4. EFGH is a dilation of figure ABCD. Explain why. So it's asking, is this guy a dilation of this guy? So we got to explain. Make sure you explain. Okay? Don't lose out on points just because you didn't give your reasoning. Okay? We care about your thought. All right, so here we go. You could go ahead and draw your to connect your points just like number 1. So A to E, it's up 3 over 2. Yeah. And I'm just going to keep following that pattern. Okay, so it's looking something like that. You follow the same pattern, and eventually you're going to just cut across. Again, I don't have a ruler, but I'm pretending. I'm trying to be as accurate as I can. From B to F, it looks like you go right 3, up 4. Okay, and if you follow that same pattern, looks like we're going through the origin again. Okay. So let's double check with all your other points. Nice. Looks like we're coming through the origin again. And so it looks like the explosion not logistics. There's a job I turned down for the feds, and basically we did this. It's kind of dark though. It's basically the sad side of math. Everything's shooting out from one location. Okay. All right, so we have this, and it looks like they're all from the center of dilation of 0, 0. Now, they're not asking that, but to be a dilation, you have to preserve your angles, all right, and all your points have to undergo the same scale factor. So we're going to double check the scale factors. It looks like from A to E, E, you had this distance, and then all of a sudden it went twice that distance. So I think my scale factor is already going to be 2 again. That's nice. And same thing from B to F. It looks like you had that distance, and then you went twice that. So it looks like you went through a scale factor of 2. Same thing from your center of dilation from C to G. So twice that. Then you went twice that from D to H. So that looks like they all underwent a scale factor of 2. That's a good sign. So far I'm believing it's looking good. So I think it is a dilation, but let's also think about our other definitions or properties of a proper dilation. Are all the lines, okay, AB is technically proportional to EF, right? So if they're proportional, that works. Also, if you look at the graph, they're parallel. That's usually a good indicator that the angles were preserved. So is BC parallel to FG? Yeah. All right. So it looks like the angles are preserved there. Is CD parallel to GH? Yeah. All right. Lastly, AD to EH? Yeah. So the angles are preserved. So I would say yes. Okay. And you'd probably say like because all points, okay, underwent a scale factor of 2. and the angles are preserved And if you really wanted to be really, really thorough, and I'm not going to do it because I want to keep this short and sweet, all right? You can probably do the proportionality or the lengths for each side. Okay, so if all the sides are proportional, it underwent a dilation. So you're good. All right. Number 5 is triangle MNP, a dilation triangle JKL. All right, so let's look. It looks kind of off, doesn't it? So it doesn't look like all our lines are parallel, does it? Originally we had what? MNP, originally we had JKL, so KL. Notice how KL crosses NP. So it looks like the slope changed. If the slope changed, that means these angles, these angles are not congruent. Okay, so if the angles changed, that's a dead giveaway. All right, this is not a dilation. It did not preserve your angles. Okay, so you would probably say, no, not a dilation. Angles not preserved. If you really wanted to get technical with it, you could probably also mention how they probably don't share, because it's kind of messed up, they probably don't share the same center of dilation. Okay, so if you tested that idea from, let's see, from J to M, for example, it blasts out this way from a certain direction. I'm going to assume it's the origin, maybe. I don't know. Obviously it pushed out that way. And then from N to K, or from K to N, excuse me, you went up 3 to the left 4. So you got a vector launching out that way. And that'll send you this way. Okay, so it looks like our vector for this pushed out that direction. But if you look at L and P, you went down 3 to the right 4. Okay, with that kind of vector direction. If you copied that, all right, you would go somewhere over this way. Notice how not the 3 lines, they're not intersecting all at one point. So they don't even share the same center of dilation. So chances are they're probably not even sharing, probably not even sharing the same, if they're not sharing the same dilation, center of dilation, it's not technically a dilation. It's just like a stretch, okay, or a compression, something kind of disformative. All right, moving on. All right, number 6. Finally, proportionality. Solving for x. All right, so x is a leg, and it's got to be proportional to the other leg of the other object, right? We're assuming. So the leg is proportional to the 6 foot, and this 20, okay, needs to be proportional to the other base. Okay, this guy's base is proportional to the other guy's base, because it's all about that base, no trouble. Yeah, I went there. All right, you can cross multiply, or you can be a true pro and just multiply everything by 6. You'll get x equals 6 times 20, that's 120. Divide by 10, that's easy math. 12 divided by 1 is just 12. And remember, this is 12 feet. Okay. And that's how you handle something like that. Number 7. In this figure, triangle RST is similar to triangle XYZ. Awesome. So they're already telling us they're similar. Which of the following is true? Okay. So first one, part A. RS is similar to XY. So the smallest piece is similar to the other guy's smallest piece. That checks out. Let's look at the other side. ST is proportional to YZ. So the second largest guy is proportional to the second largest guy. That makes sense. Guy is in side length, yeah, segment, line segment. So that's true. So A looks true. Let's check the other guys, just in case. RZ is proportional to XZ, so RZ, the small guy, is proportional to XZ. Whoa. Are you telling me that the poorest guy in the city is proportional to the richest guy? Nope. That does not make sense. Okay? If Chewbacca was a Wookiee, why is he on Endor and not Kashyyyk? That does not make sense. If you have no idea what I'm talking about, Wookiees, alright, like Chewbacca, he's supposed to be on Kashyyyk, his home planet, not Endor. Alright, C. RT, okay, is supposed to be, okay, so RT is the, if I'm seeing this right, it's hard to see it because I'm tired now. I think RT is the longest line segment. Yeah, I hope. Measure, double check. All right, so if RT is supposed to be the longest, then he is proportional to XZ, which I also think is the longest visually. Okay, so that makes sense. All right, the richest guy is proportional to the other rich guy. And then RS, the poorest guy, or the smallest guy, is proportional to YZ. Whoa. That doesn't make sense. All right. Poor guy should not be proportional to the middle class guy. Okay, so that part doesn't check out. All right, so let's double check D, because you never know. You might have that one problem that has multiple answers. So make sure, double check. Don't lose out on points just because you weren't thorough. RT, supposedly the longest guy, is proportional to XY. Alright, so that doesn't make sense because XY is the poor guy, and RT for this triangle is the richest guy. That doesn't make sense. So it looks like your answer for this one is A. Okay. Which of the following is true? Alright, so that's singular, so that's good to know. Alright, number 8. This is a good one. Okay. Are these triangles similar? Explain. So again, explain. Make sure you explain. Alright, don't lose points just because you didn't want to share your process. They're telling us that angle T is congruent to angle N, and that angle M, okay, is congruent to angle V. Good to know. So since two angles are the same, or congruent, okay, that's the word, you can say, yes, they are similar, okay, and you'd probably say, yes, triangle AMT is similar to triangle BVN, since, or by, okay, it's up to you, the AA angle similarity, triangle similarity theorem. Okay? You could also probably mention, triangle sum theorem. So if the triangle sum theorem, if those two angles are the same, then obviously angle A is going to be congruent to angle B. And since all the angles were preserved, therefore by the definition of dilation, right, they are both similar. You could probably say that. Make sure you mention angle similarity, triangle similarity theorem. That'll make your teacher happy. All right, number 9. I'll use the figures 9 and 10. Okay, so name one additional piece of information that is sufficient to prove that triangles are similar. So we have a side. We have a side. We have a side. We have a side. Side, 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 side. Remember, there's 3 different types of similarity theorems. AA. Do we have 2 angles? No. We have SAS. And remember, they just want one additional piece, okay? Well, if they gave us this angle to be incongruent to this angle, wouldn't that just give us SAS? All right, ding ding, that could work. So you would probably have to say that they have to show us that angle C is congruent to angle R. That would definitely work, okay? And then you have to explain, because you can use the SAS, similarity theorem, and then there you go, ding ding ding, all right? You could also play it dangerously, and a different answer, which would actually be correct, is, well, if they gave us another side, like if they told us that dt, all right, was proportional to, let's see, FL, all right, then yeah, you could use side, side, side similarity, okay? But the clearest and most evident answer that would just make your teacher smile instantly would be this reasoning, okay? If they gave you one angle, you could use SAS, similarity theorem. All right, now statements. Statements are, well, they're pretty extensive, and I believe on your test you need at least 6 for full credit. So first things first, let me clear it up a little bit so you can see visually what's going on. So this small guy, all right, CT, should be proportional to RF. So CT to RF, and we're going to compare them to another side, which CD, and it looks like, yeah, LR would work. So you have CD is proportional to LR. That works. Now another way you can write this, okay, is you can write CT, all right, is proportional, all right, to RF, and then let me do this right because it's always a little tricky. Then you would say F. Oh, let me think. Oh, I'm so tired. CT is to CD. Why am I going brain dead right now? Okay. Oh yeah, there we go. CD, all right, to LR. So notice how I did originally the small guy with the small guy, and then the second medium to the second medium. But then all of a sudden I did the small guy to the small guy, and then that's all over the medium guy in the denominators. Okay, I just swapped them around. That's another way you could have done it. So we got 2 so far. Let's go ahead and make another one. So we could say, well, what about TD, the biggest guy, the base, and LF? So you would probably have to say, well, TD should be proportional to FL. And then you could pick the smaller guy if you want. It's up to you. Or the medium guy. I'll pick the smaller guy. And that's proportional to TC all over FR. Okay, that would work. Okay, you could rewrite it just like how I did with the other one. So instead of the big guy over the other big guy, it's the big guy with the other big guy. And then the small guy to the small guy on the right. You'll get the same answer if you were dealing with numbers. All right, 4 down, 2 to go. Oh boy. So the last 2, you could pick the small guy with the medium guy. I think that's what I did originally. So I'll do the big guy with the medium guy. So big guy is proportional to the big guy. And that's proportional to the medium guy, which is CD over RL. And then if you rewrote him, instead of putting the big guy over the big guy equaling the medium guy with the medium guy, what you could do is you could do the big guy, oops, wrong letter, with the other big guy, and that's all over the medium guys, CD and LR. And yeah, I don't know why my alphabet is just mixing up. I'm very tired. There we go. All right, good luck. And there's your 6. Okay, 1, 2, 3, 4, 5, 6. And so if you know how to set up your proportionalities, you're good. If you do all 6, you get full credit. If you do, I think, up to 4, you get 2 points. If you do 3 or less, you only get 1 point. If you can't get more than 3, I don't think you get anything. Talk to your teacher. All right, good luck.